Well, it's a pleasure to see Emily here virtually. She's my colleague at the University of Washington in Seattle. She got her PhD in 2010 at the University of Hawaii. And then for 5 years, she was at the University of Colorado, first as an Einstein Fellow and then as a Hubble Fellow. Since 2015, she is at the University of Washington in Seattle, and that is where we met. I had been teaching there the graduate course on stellar evolution since 2004, I think. And in 2016, Emily took over my class, and she did this very well. At the request of the American Astronomical Society, we then started to write a book together, a new textbook about stellar astronomy, and it's called Understanding Stellar Evolution. And I think, Emily, I heard that it's doing very well and is now used at many universities as a textbook. Emily mainly works on stellar evolution, and then mainly massive stars, red giants, luminous blue variables, Wolf-Rayet stars, single stars, binaries. And she may be the first one to have discovered a Zhidkov object. Also, as you know, that's a massive star with a neutron star inside. But I think the jury is still out there, whether it was really the first discovery, but it looks promising. She recently got a very high prize, the Newton-Lacey Pierce Prize of the American Astronomical Society, and let me read it. The prize is awarded annually for outstanding achievement over the past 5 years in observational research by a young astronomer. And Emily fully deserves this. Not just this, but along the way, she collected a large number of awards. I'll just mention the Annie Jump Cannon Awards and the Robert Trumpler Award and several others. I think almost every possible award that could have been given to you was actually given to you. But today, Emily is going to talk about something very different. Since the last few years, she was traveling all over the world to very remote and strange places. She even flew on the Kuiper Airborne Observatory to get a feeling of the history of astronomy in the last, let's say, half a century or so. And that's what she's going to talk about today. It's called The Last Stargazers, Astronomy Adventures and the Scientific Power of Storytelling. And that's also the title of her book that she's writing now, and I think that's going to be published this summer, isn't it, Emily?
Yes, August 4th.
Well, the virtual floor is yours. Go ahead.
All right. Thank you. Good, very early morning from Seattle to everyone. And thank you so much for inviting me to come virtually present. I look forward to getting the chance to hopefully coming out and visiting everyone in person someday. So Henny talked a little bit about the research that I do on massive stars, and also mentioned my book that's coming out later this summer, which is what this presentation is based off of. So the way that I put this together was a presentation for my fellow astronomers on some of what I've been doing over the past couple of years in researching this book and learning about the scientific power of storytelling as a way to get the public excited about astronomy. So to explain where this book came from, I actually need to go back to my very first set of observing experiences. So my first observing run was in 2004 at Kitt Peak Observatory in Arizona. I was halfway through my undergraduate degree. I just struggled through some unbelievably difficult classes at MIT, and I was really ready to try actual professional astronomy for the first time. I showed up in Arizona. My collaborator, Phil Massey, who I was meeting for the first time then, and I've now gone on to work with for 15 years, picked me up at the airport, drove me up to Kitt Peak, and I saw a professional observatory for the first time. I had really no idea what to expect beyond knowing that there were going to be telescopes and they were going to be huge. So that evening, we sat down at dinner and Phil introduced me to everyone around the table and told them that it was my first observing run. So everyone immediately said, "Oh, that's great." Started giving me tips for my first observing run. And it then started turning into storytelling. So people were saying things like, careful, once 3 a.m. hits, really silly things start happening. There was somebody who was observing alone once and locked themselves in the bathroom and lost telescope time before they could get out. Someone else was saying, oh, you're on the 2.1 meter. I was in there once when it got struck by lightning. It's the loudest sound I've ever heard in my life. And then someone else would pick up and say, you know, you really need to look out for scorpions in Arizona. They sting, they're dangerous. Someone here got stung by one and it was incredibly dramatic. And I remember sitting at dinner, just sort of eating and being mesmerized, because these were my first glimpses at what the job of being an astronomer was actually going to be like. I learned the nuts and bolts of astronomy in school, but these stories were my first sort of window into what my job would be like if I started doing this for a career. So fact-checking the stories that I just told you, because we know fact-checking is very important these days. The observer getting locked in the bathroom is real. It's now immortalized in their research papers methods section. 15 minutes were lost because the observer got locked up in the bathroom due to a broken door handle. The lightning strike was quite true, and I've actually talked to a number of observers that have had that happen to them. Lightning strikes are pretty frequent at Kitt Peak. The scorpion sting story is real. My colleague who now works down the hall from me was actually the unfortunate scorpion sting victim. She's fine. It was maybe not quite as dramatic as the story had evolved to be over the years, so there was a bit of a exaggeration that started coming into these stories. But these were just a few of the stories that I wound up hearing from people as they told me about what observing would be like. So at Kitt Peak, I went on to have a fantastic 5 clear nights. I had perfect beginner's luck at the telescope. And I got data for a project studying red supergiants that's actually still going on today. So it was a wonderful start to my observing career. So if we then fast forward from 2004 to over a decade later, I was at the American Astronomical Society meeting in Texas that year. And I had talked to a couple of people because in part of the book that Henny and I had been working on together, this textbook. And somebody asked me, you know, you're working on academic books. Have you ever thought about writing a popular science book? And I immediately said, no, I don't think so. It's not something I've ever really had an idea for, but let's meet and chat about it anyway. And as we met and talked, the idea for The Last Stargazers popped out of my head. Because what I'd realized is that these observing stories are the tales that we all tell each other when we're at a conference dinner, or when we're talking before a colloquium, or when we're all just, you know, sharing our own experiences. They're the stories that we like to tell, and they're the stories that really resonate when we talk to the public. So there's a really exciting possibility there for using these stories to show people what astronomers actually do. And this was where the idea came from. It's pretty easy to sell people on the idea that space is fascinating. People love Hubble photos. People love little factoids about how far away stars are or how black holes work. But most people really don't know that much about what astronomers actually do. I did the math out, and there's something like 50,000 professional astronomers on Earth out of 7.5 billion people. So it's maybe not that surprising that people don't know the ins and outs of our job, but our job is pretty unusual. We head out to the middle of nowhere to do field work. We're doing almost all of our work based on things we can't touch, based on nothing but light that we're able to gather. So it makes for a very unique and interesting little corner of science. So what I wanted to do was build a book around observing stories that could teach people the science and the motivations behind how we use telescopes, that could humanize astronomy and kind of put a personal face on it, to explain to people how we do our research, why we do this research, and why it matters, and to kind of explain how the field is evolving and changing. Because anyone that's been an observer for any length of time has seen how dramatically technology has changed what we do. And it seemed like a good chance to kind of save how we've been doing research for the past half century or so, and then look ahead to where we're going. So that all culminated in this. This is my book, The Last Stargazers. It's coming out, it's being published in the US on August 4th of this year. There's also a UK publisher that'll be publishing it on August 6th, and I'll have this information again at the end. But it was pretty exciting to see this turn from an idea into a book. It was admittedly a slightly different process than I was expecting. When I first embarked on this, I had this idea that there would be a fairly nice, neat process for how to write a scientific popular book. You would do some research, you would write it, you'd edit it, and then hopefully you'd sell it and people would buy it, and that would be it. The actual process was a little bit lengthier. I'm happy to chat with folks who are interested in getting into the world of popular science publishing, because it was it had many more moving parts than I was expecting. And it's still going on. We're still doing work in the lead up to the book's release. But it was an interesting comparison to writing an academic book, and a really enjoyable experience to actually research it. As part of researching the book, I got to go all over the world between existing trips that I was taking for work and then personal trips specifically for book research. So on the upper left of this slide is a picture of me inside the sort of central room of the LIGO interferometer out here in Eastern Washington. I got lucky in that I could just drive out there. So I got the chance to visit a gravitational wave observatory and learn all about how they do their work. The picture on the upper right is SOFIA, so the Stratospheric Observatory for Infrared Astronomy, which I was lucky enough to fly on both as a writer and then as a researcher to see what it's like to actually work on an observatory operating out the open back door of a plane, which was unbelievable. On the lower left is the summit of Mauna Kea. That's where I did a lot of my thesis research in graduate school, and a mountain that I very much wanted to visit to learn about because it's such a interesting but complicated place in the way that we do observational astronomy today. Down in the middle was a photo from a quick trip to Palomar Observatory down in California. And on the right was the most exciting and important part of my research. This was my trusty voice recorder that I used to record interviews with all of the astronomers that I talked to. In the end, I interviewed 112 people for the book. I really wanted to get a mix of career stages of people coming from different backgrounds. I talked to folks who worked as telescope operators, really heard from a lot of different wavelengths that can be done from the ground. We got a little generous with our definition of ground-based with something like SOFIA, but I wanted to get a big sample of different observing tales and different observing experiences that I could try and synthesize in the book. So there were three questions that I tended to wind up asking everyone. And these were the three, and I'm going to use these as sort of the structure of the talk. One thing that I loved asking people, everyone was very eager to tell me their own observing stories, but one thing I was trying to get at was the stories that had kind of sunk into the field and had turned into almost legends and grown lives of their own, and the stories that people most love telling as they go around. So one question I asked everybody was, what is your favorite secondhand or third-hand or 10th-hand observing story? The story that you absolutely do not think you can tell reliably, but that you know you've heard and that you loved hearing about. So that's what I wanted to start with. And the most common answer for this by far, especially talking to a lot of astronomers here in the US, was, do you have the one about the telescope that got shot? So for those who don't know this story, this happened in Texas, yes, at McDonald Observatory at the 107-inch telescope. So this story had absolutely grown a life of its own in the 50 years since it had happened. This happened back in 1970 when the 107-inch had fairly recently been built. And depending on who you ask, there's a gunman involved because it ends with the telescope being shot. And people were saying this was a frustrated astronomer. I think there's a version where it's somebody dealing with like a spurned love affair or some very dramatic tale. And in reality, it was an observatory employee who had grown disturbed and disgruntled. And in the middle of an observing night, he decided he was hell-bent on destroying the mirror of the 107-inch telescope. So he charged into the telescope with a gun and pointed it at the telescope operator and insisted that the operator lower the telescope so that it was facing towards as low as possible so that he could get out the mirror. And he then fired and emptied the gun into the mirror in the hopes that this would destroy it. But remember, telescope mirrors are huge. They're a couple feet thick. They're this immense, heavy borosilicate glass. So he, I imagine, was hoping the bullets would shatter the mirror. And instead it did this. The bullets just kind of thunked into the mirror like darts being thrown at a dartboard, and no serious damage was managed. So he got frustrated, he threw the gun away, he then started trying to go after the mirror with a hammer, But by then, people had called the authorities, the sheriff showed up, and he was apprehended and taken away. So now we're left with a telescope that's just been shot. And the sheriff peered into the telescope. It's pretty similar to the view that you can see here. And then immediately said, my God, the telescope has this huge hole in the middle. It's been destroyed, because the sheriff didn't know what the Cassegrain focus was. So word got out that this telescope had been irreparably damaged. And the observatory director actually had to send around a astronomy telegram style update explaining, no, the telescope is actually fine. We were actually able to just get in and dig out the bullet holes and paint them over. You can see the little black spots in this image. Paint them over so there won't be reflections. We've really just turned the 107-inch telescope into 106-inch because we've lost a little collecting area. And in short, the harm suffered from the bullets was extraordinarily small, which has to be one of the more unusual sentences ever written in an ATAL. So astronomers tell this story to each other, and we immediately get some of the absurdity of it. But if you tell this to a random person who's just curious about what astronomers do, they're going to have a lot of questions. Why do we call a telescope the 107-inch? That's a terrible name. Why does the size of the mirror matter the way that it does? What does a telescope operator actually do? There was a telescope operator involved in the story, and a lot of folks think astronomers operate their own telescopes. Why didn't those bullets shatter the glass? You have to understand the nature of a telescope mirror to know that. What is that big hole for? They might respond to it the same way that the sheriff did. And is this really terribly dramatic? It's just one telescope. How many telescopes are there in the world? How many can do this sort of research? What kind of impact would something like this have? So this is a great example of a story that you can tell people that's very unusual and very dramatic, but that requires learning a lot of science along the way in order to completely understand it. So this was far and away the most popular secondhand or legend story that I got from people, and it's most certainly been included in the book, but it comes along with a lot of lessons for people reading the book about how to understand exactly why the story works out as it does. So another question that I asked people was, what stories did they think would most surprise sort of the average person reading this book? And I think the most common answer that I got to this was connected to the idea that astronomers don't look through eyepieces. People imagine an astronomer as somebody who's literally peering through a telescope and maybe writing down or taking notes on what we see. And a lot of stories focused on what we use instead of eyepieces. One of my favorite set of stories to hear about was these stories about photographic plates and what we used in place of eyepieces several decades ago. So the story of how photographic plates work has now expanded to be an entire chapter of the book, looking at how we used to observe and how technology has evolved astronomy from 100 or so years ago up through today. I talked to lots of folks that had worked with photographic plates, and the stories and the care that went into these plates were just fascinating. You would order a glass plate from somewhere like Kodak or a company that manufactured these, and the plate would come with a silver emulsion coated on one side that would react to light. When you exposed the plate to light, that emulsion would darken. So if you placed that plate at the focus of a telescope and then opened the telescope's shutter, you'd get this nice little darkened image of a star or a galaxy or a spectrum or whatever it was you were observing. But to get the plate to behave, a lot of work had to be done to it. You had to slice the plate down to the right size to fit into a camera. People would try all sorts of tricks on these plates to make them respond to light faster, because the faster the plate responded, the shorter your exposures could be. So people would bake plates or freeze them. I know one person swore by coating them in lemon juice, or you would dunk them in an ammonia bath, which was an absurd smell to be dealing with while you were working on these plates. And all of this work had to be done in darkness, because once the plate was exposed to light, you were done. You had to basically keep the plate as dark and as protected as possible until it was loaded into the telescope was pointed to an object, and you would then open the shutter. So people would do all of this careful work on plates. They would take them out to the telescope, and at the time, you were usually observing right beside the telescope. You would wind up in something like the prime focus cage. So this is a picture of Edwin Hubble sitting in the prime focus of the 200-inch telescope at Palomar. So you would bring your plates to the telescope, climb into that cage, the telescope would rise into the air with you at the prime focus, and you would then load plates in and out, carefully guide the telescope, and stay out there all night, oftentimes freezing cold, and spending hours and hours exposing a single plate on something like a faint galaxy. So it was an incredibly labor-intensive way to observe. There were plates that would actually get exposed for entire nights or even multiple nights. You could load in a plate, point to a faint galaxy, open the shutter, spend all night painstakingly guiding the telescope yourself on that one galaxy. Get to the end of the night, close the shutter, get down from the telescope, go to bed, come back the next day, turn back and center on that galaxy, and then open the plate again. So people would spend multiple nights sometimes trying to get one perfect plate of a very faint galaxy. So there was an observer doing this one night at the largest telescope at Lick Observatory in California. And it was a plate like this where it had taken hours, days of effort, and had been very painstakingly prepared and exposed on a very faint object. So this particular observer was known for being a little quiet, not perhaps the most friendly or the most talkative person. And they'd been observing up at the top of this telescope for hours in total silence. Now, at this telescope, like at almost any big telescope at the time, he had a night assistant working with him. And the night assistant had realized he hadn't heard anything from his astronomer in a while. They were just sitting up at the prime focus. And they decided to walk into the dome during the evening just to check on him and see how things were going. Now, as the night assistant walked into the dome, his coat caught on the wall and flipped the light switch in the dome. So the lights then came blazing on in the dome, of course, completely destroying this plate that the observer had been working on so carefully and so patiently. And this pretty quiet, non-talkative observer got a lot less quiet. There was this howl of fury from the top of the telescope, and the observer starts shouting, "What have you done? How dare you? This is a disaster. I am going to get down from this telescope and kill you." And he then, to do that, has to start turning the telescope. And we all know how fast telescopes move. So he's slowly turning the telescope over to the elevator mounted on the wall of the dome so that he can climb down and presumably go about murdering the night assistant. Now, the astronomer can control the telescope, but the night assistant, among their other responsibilities, controls the dome. So the night assistant on the ground was thinking, my God, he seems really mad. He might be serious about killing me. I might not want to let him down. So as the telescope is spinning toward the elevator, the dome suddenly swings into motion as the night assistant starts turning it, dragging the elevator away from the observer. And the end result is the middle of the night at this beautiful observatory in California, with the largest telescope on the mountain spinning in circles with the lights on. And the night assistant just yelling, calm down, I'm not letting you out until you calm down. I heard the story from several people, and everyone imagined what this must have looked like from the outside. Imagine being at one of the other telescopes on the mountain and then looking and going, what are they doing? Why are they spinning the telescope with the lights on in the middle of the night? So it was a great example of how this sort of observing could, go a bit wrong, but ties back to this idea of we don't look through eyepieces. We've had different tools at our disposal for decades, and some of those really require a lot of care and can sometimes go pretty wrong. So I got a few answers to this question of what stories that I think would surprise people. Another thing that a lot of astronomers brought up were some of the adventures and some of the extremes that we go to get data in astronomy. And a lot of these tie into the fact that we have to put our observatories out in the middle of nowhere, and that we have to go to remote mountains, often by ourselves, often fairly cut off, especially in the past few decades, especially a few decades ago, fairly cut off from civilization and news in places where the happenings of the outside world can sometimes take us by surprise. So this is Monastash Ridge Observatory. It's a small observatory at the University of Washington. This is why the photo is labeled here. And it's run by the University of Washington. It's down in southern Washington state, in a pretty quiet and remote part of the northwestern US. So we still use this telescope as a teaching tool and to do a little bit of observing. And several decades ago, it was a good research telescope for graduate students at the University of Washington trying to do their PhD work. So there was a graduate student here named Doug Geisler, who back in 1980 traveled out to Monastash Ridge to get what turned out to be the first night of observations for his PhD thesis. He was just beginning his thesis research. And like any good astronomer, he kept a detailed night log. And you can see how his night log starts. The first night of his thesis observations went great. He had 10 clear hours. The sky conditions were wonderful. The clouds cleared away. He got great seeing. And this was supposed to be the first of several nights of observing. So he went to bed at 5 a.m. on May 18th, 1980, thinking, I'll get up tomorrow and do another great round of observing. So for a lot of us, May 18th, 1980 really doesn't ring a bell, but for a lot of people in the Pacific Northwest in the US, this is a pretty significant date. He woke up early that morning, having heard this sort of strange, distant booming sound. And at the time, he barely thought of it. He went back to sleep, and he woke up a few hours later around noon, when astronomers tend to wake up. And he opens the door to, head out and greet the day, and the world around him has gone black. He can't see more than 10 feet in front of him. The air smells like sulfur and just smells terrible. And he's alone on the mountain. He did not have observing assistant. There was nobody else on the mountain, and he was just standing there going, my God, I'm standing in the end of the world. And what had happened, which he would learn about in a few hours, was that Mount St. Helens had erupted that morning. This is a massive volcanic eruption, and the eruption had actually blown off the side of the mountain, and it had sent this enormous thick plume of volcanic ash blasting across eastern Washington. So to understand what that means, Mount St. Helens was to the southwest of Monastash Ridge, and that plume blew to the northeast. So this is ultimately what happened. That's the eruption. That's where Doug was, at the summit of Monastash Ridge Observatory. So the volcanic plume had blown directly over the observatory and directly over him. He finally got word of what had happened. He had to run to a radio and try to desperately tune in a news station that was explaining Mount St. Helens has erupted. Here's what's going on. Being a good, responsible observer, he closed up the telescope tight to make sure that ash wouldn't settle onto the mirror. And then he wrote a night log entry. So you can see on the bottom of his night log entry, hours lost, 6, reason, volcano, sky conditions, black and smelly. So it's gone down in history as one of the more epic night observing log entries that anybody's ever written. And I still think, even after having talked to colleagues from Hawaii, that this is the most extraordinary volcano-related observatory I've ever heard. So his night log entry has now actually lent me a chapter title in the book. The title of chapter 4 is now Hours Lost 6, Reason Volcano. You can also see in this list that chapter 5 is where the telescope getting shot tale goes, because that one is titled The Harm from the Bullets Was Extraordinarily Small. So Monastash Ridge was one example of a observatory out in the middle of nowhere that we go to for our research. In the list of extremes that we go to get data, it's one of many. So these are some of the other stories that I got for the book about the adventures that people undertake to observe. So that picture on the upper right is from a solar eclipse in Svalbard, Norway. I interviewed Shadia Habal, who's traveled to eclipses all over the world, bringing her telescope and bringing her team and equipment with her to get observations of the sun during eclipse. So following eclipse astronomers and the expeditions they have to go to observe was a wonderful set of stories to get. On the upper left again is Sophia, this really incredible telescope that will actually fly into the stratosphere and take astronomers and the team of operators along with it. So that's an example of us literally trying to just get as high as possible. It's even eclipsed by balloon observations. So the photo on the lower left is from a research balloon launch, in that case in Antarctica. But I talked to balloon astronomers who had launched balloons from the US, from Australia, and actually sent detectors as high as you can possibly get things, really without launching directly into space, but working from the ground. So there's some pretty epic mishaps that can happen from balloon astronomy that I heard about as part of gathering these stories. The photo in the bottom center is the South Pole telescope, and I talked to observers who had wintered over at the South Pole, observers who had helped work on this telescope as one of the elements in the interferometer that took a photo of a black hole. And there's absolutely, I can't imagine a better adventure than traveling to one of the poles and doing astronomy there. So hearing about what their lives were like as they wintered over was a really excellent glimpse into extreme astronomy. And then finally, I stretched my definition of ground-based astronomy just a little bit because I couldn't resist putting in the telescope on the lower right. So that little gold telescope is an ultraviolet telescope. And the man standing next to it is George Carruthers, who was the person who invented the ultraviolet camera and spectrograph and designed and built this telescope. This telescope was ground-based in that it sat on the ground. And if you're a little suspicious because you heard ultraviolet and ground-based and you're going, well, that doesn't really work. This telescope wasn't on the ground here on Earth. It was the only telescope that we've ever put on the moon. This telescope flew on Apollo 16 and was set up in the shadow of the lunar lander. Astronauts John Young and Charlie Duke operated it during their time on the moon. And it was some of the first ultraviolet observations we were able to get. We pointed it back at Earth and got UV observations of our own planet. We got great early UV observations of stars in the Milky Way. So it was a really clear extreme of traveling about as far as you can to do some good ground-based astronomy. So the last set of stories that people liked telling me that they thought would be surprising or entertaining to people are the class of kind of accidental discoveries. And everybody loves stories like this, stories of scientists detecting what they think is one thing that then turns out to be something else. And the classic version of this was the potassium flare stars, which a few of you might sort of half remember. This was another very popular second or third hand story that people would tell me. So potassium flare stars were discovered at Haute-Provence Observatory in France, and this was back in the early 1960s. Some observers were taking spectra of stars and got the spectra back and were examining them and realized that they were seeing these really dramatic flares in the stars. They were incredibly surprised with what they found. They were seeing what looked to be a very strong flare that was specifically concentrated in the element potassium. So they were seeing a sudden bright appearance of potassium lines that then disappeared. They found these fascinating, and they wrote up a paper saying, look, we've discovered potassium flares in 3 different stars. And they were 3 stars that were totally different from one another. Like one was a B star, one was a colder star, one was a strong magnetic field star. There was no clear connection between the 3 of them, except that they'd all obviously exhibited a potassium flare. This paper came out, people were fascinated, and other observers obviously wanted to go find these as well, and they never really managed it. Nobody else was detecting potassium flare stars. In fact, the only people detecting potassium flare stars were this research group at this telescope, which started to get a little bit suspicious. So a group in California finally decided to dig into this and see if they could explain where these potassium flares were actually coming from. So I showed the view down the McDonald telescope earlier, which was this classic Cassegrain design that we all know. The detections of potassium flare stars in France were coming from a Coudet feed setup. So in the Cassegrain setup, we bounce light off a primary, then off a secondary, and then back to a detector. In a Coudet model, we go through a lot more bounces. We have some tertiary mirrors, and the detector will sometimes wind up in a totally separate room. In Haute-Provence, this room turned out to be a fairly convenient break room where people would go in to take a break and perhaps take a smoke break. One of the observers on this team was known for being a pipe smoker. And as it turns out, potassium is the strongest element in the spectrum of a match. So the team in California realized that this might be the case, and they wrote this wonderful paper on the spectrum of a match and how you could detect this at a Coudet feed if you stood in the right place and the light from the match reflected down. It was wonderfully done. They write a great acknowledgement in the paper saying, we would like to thank George Preston for authorizing our unorthodox use of the 120-inch Coudet spectrograph, because I have to imagine that their proposal was some version of, we would like to go into a telescope dome and play with matches. But George Preston said yes. And the end of the paper is really great. They go through breaking down, we tested book matches, safety matches, kitchen matches. They contacted the observers in France who were completely on board with working on this as an explanation, and they tested their own matches. So there's a sentence in the paper saying there's no difference between French and American matches, but there's a little table with like the spectral lines in a match head. It's a wonderful paper. So this seemed to pretty conclusively debunk potassium flare stars, but there was one more catch. Just a few years later, there was another paper on a red supergiant called VY Canis Majoris that actually had emission lines of potassium in its spectrum. And George Wallerstein was one of the authors of this paper and took the observation. He also knew the potassium flare match explanation very well. And he cited that paper to take great care and assure people that his potassium emission lines were real. And the whole explanation ends with, the explanation from that paper does not apply because the observer does not smoke. There were no matches being struck. There's no way this could be the same explanation. So we did find some real potassium emission, but we had to debunk the match explanation along the way. So there's another fake discovery or surprise discovery story that I suspect a lot of you may have heard. I don't often get to tell this story when the participant might be on the call. I'm not sure if Emily Petrov is here, but this is the story of fast radio bursts and perytons. So this happened at the Parkes radio telescope in Australia. And in 2007, Parkes reported the discovery of something called a fast radio burst. And when this discovery was coming out and when people were starting to look at fast radio bursts as potential exciting scientific targets, there was a pretty early answer of, oh, we've been detecting these all the time. We get these blasts of radio emission from all over the sky, and we're pretty sure they're just some kind of ground-based interference, but we just don't know what. These had actually been nicknamed perytons. They're these mythical creatures. They're stags with bird wings that cast the shadow of a person. So it's something that appears to be one thing, but its shadow tells us it's something else. And for a long time, I think people were just sort of accepting, perytons, they're this weird thing. But disentangling perytons from fast radio bursts, when Emily Petrov went to Parkes to start studying fast radio bursts, she took it as a challenge, saying, we have to explain what the perytons are so that we can keep working with true fast radio bursts. So she and the observatory staff embarked on this amazing paper trying to figure out what perytons are. And one of the early, if you look at the overall area where the Parkes telescope is, you've got the big main radio, and then you've got some nice visitor center buildings, staff buildings, visitors quarters. An early indication that the perytons might be coming from Earth was that they were clustering around the lunchtime. So this was a sign that there was something terrestrial going on. The team tested every bit of electronics they could on site, including the microwaves on site. They would run a wave, they would put in a cup of water, or they would put in a meal and run it, and then realize, no, we didn't make a peryton. Maybe the microwaves aren't it. We're not really sure what's going on. And finally, they hit upon data telling them that it was the microwaves, but with a bit of a catch. So if you've ever used a microwave to make popcorn or an easy dinner, knows that you'll be standing waiting for the microwave to finish. And as the last seconds count down, you might just go, oh, close enough, and open the door to stop the microwave before it's completely counted down its cycle. They realized that if people were opening microwave doors while the microwaves were still running, they would emit a short blast of radio waves that would be detected as a peryton. This other paper where it is just delightfully detailed in doing very careful science, even if it might have felt absurd at the time. They were taking notes on the power that they ran the microwaves on what was in the microwave. I'm sure someone dug deep into a microwave manual to explain exactly why they were getting this blast of light. And when they finally did this, running the microwave and opening the door, they were able to make a peryton. Emily told me the story of getting this news from the Parkes staff while she was away on a trip and writing the paper in this immense burst as she was home because they were so excited to finally explain what they'd seen. And the author list of this paper includes everybody who was on the staff at Parkes because it had been this collective search to try out what on-site could have been making these signals. So they'd explained perytons, which seems like you then eliminate all these bursts of radio emission that the telescope was detecting. And it did eliminate most of them, but it did not eliminate the burst that had been detected in 2007. That was a real fast radio burst. And we all know today that fast radio bursts are these incredibly interesting, mysterious, actively studied phenomena in radio. But to isolate these and study them, we had to do the microwave search first. So this is a great story of, the things that people can detect possibly by accident that we have to explain before we can get to the things that we're detecting from the universe. It's also a great glimpse into some of the sources of interference and noise that we get here on Earth, and the challenge of trying to observe when it's cloudy or when there's light pollution, or in the case of a telescope, when there's a microwave or anything that can create radio interference running on the ground. So the last question that I asked people was, how has astronomy changed since you began observing? I wanted to hear from people on what they saw evolving in this and where they thought the field was heading. And this was a really interesting tour, going from things like plate-based astronomy. So this is the photographic plate that Edwin Hubble took. He discovered a Cepheid in M31. This was the plate that eventually led to the discovery that M31 was a separate galaxy and really just changed our picture of the whole shape of the universe. We've gone from these sorts of M31 observations to these M31 objects. So this is just a tiny piece of the Andromeda Galaxy taken as part of Hubble's enormous survey of all of the stars in M31. So the technology of astronomy is changing very dramatically. And that goes beyond just the type of data that we get, and also gets into the manner in which we observe. So one thing I got to do as part of researching this book was visit the Vera Observatory site down in Chile. So formerly known as LSST, now wonderfully named after Vera Rubin. This telescope should be coming online in another year or two. When I was there, you were just constructing the dome. I think the primary mirror was on a boat at the time, making its way to Chile. But it was fascinating to visit this sort of next generation observatory, because Rubin Observatory is going to be almost taking a movie of the entire southern sky. It's going to imaging a huge swath of the sky over and over every few days for 10 years. And that data is going to be stored in immense quantities for people to use for domain astronomy. And that observatory is operating with almost no one there. As it is following a preset program, an observer doesn't have to travel up the mountain and go there and sit there all night running through a planned program. The observatory essentially has a telescope operator, one or two other folks on the mountain for safety, and that's it. It was really interesting to see how this facility was being built and comparing it to places like Palomar, California, that had been operating since the early 1900s. This is maybe the most extreme example of observing where the astronomer is no longer at the telescope, but we know of a lot of others. We know that things like the Gemini telescopes will operate on an observing queue. The telescope University of Washington uses is operated remotely. I can run it from my laptop sitting on a couch and communicate with the telescope operator on the mountain to do observations from my home. We also have robotic telescopes that don't have anybody on site at all and can just remotely sense through different tasks. So this was something that a lot of people brought up and that occasionally had mixed feelings about. And it had nothing to do with the science. I think everybody agreed that these were all exciting scientific advances, but people were a little sad that they didn't get to go to the mountain anymore. It's especially interesting to look at this aspect of astronomy now when nobody is traveling much of anywhere, and look at the remote capabilities or few capabilities that we developed. And it's wonderful because it means that some telescopes still operate. Those telescopes also do still have people on site. So it's become a very unusual look at how the way that we observe has evolved. I think that this tied into one of the key points that I wanted to make in the book, which is that the role of a stargazer and the role of an astronomer is changing with time. These are tied back into one last question that I always liked to ask people. I asked everyone what their most vivid memory was of observing. And what I was looking for was sense memory, saying if you shut your eyes and imagine yourself standing at a telescope, imagine yourself on an observing run, what comes to mind? And people would remember the sound of the dome turning, like that scraping noise as the dome moves. Or they would remember the smell of burned coffee in the warm room kitchen, or the smell of machine oil that just gets into the walls of old observatories. And they were recalling all these beautiful experiences that they got in person, heading to these beautiful mountaintops in Chile, or watching sunsets, heading out to these beautiful remote places where you can really get to an amazing quiet area and take great observations. My most vivid memory for sure is going to be flying with Sophia, because we flew almost down to Antarctica and we actually got to see the southern lights, the aurora australis, out the windows of the plane. It was my first time ever seeing the aurora, and I'll never ever forget the sight. These were all wonderful human experiences that I wanted to round and share in the book, but I wanted to do it with an eye on the science as well. So the title of my book is The Last Stargazers, and this is something a lot of people have asked me about. I think a lot of my fellow astronomers were concerned that I was writing some sort of technology book saying, oh no, we're destroying astronomy by not putting people in the telescope. And when I spoke to publishers, some of them wanted that book. They wanted a book that would complain about technology and say that automation and computers were destroying astronomy's soul. And it was that I absolutely didn't want to write. It's not how I think most of us think of it, and it's not true. What I wanted to do was take this book and examine how astronomers' role and place in astronomy is changing. So, as technology has become better at studying the universe, it's always worth considering, where do we need the technology and where do we need the people? Sometimes the technology makes it possible for us to observe in situations right now where it's very hard to physically get someone there. We also still need people designing the technology, working with the data, interpreting the data. So there's absolutely still a place for stargaze in professional astronomy. We just might stargaze in a slightly different way now. I also wanted this book to be a chance to write down stories from an era that really isn't coming back. We're not going to go back to photographic plates, and we're not going to go back to writing in the prime focus cage. I actually tried to find an observatory that would let me do prime focus observations, and I couldn't. This seems to largely be a past. But these were wonderful stories about how we did some really incredible science. So I want to serve the human tales and experiences of that, and use the storytelling to teach people, share how we do our research and how the research has evolved. And then finally, I think it's a good to humanize space and humanize scientists. Astronomy can sometimes like a kind of remote and a little bit of a irrelevant field to a lot of people. You'll get things like, why are you studying stars? Shouldn't you be studying medicine? Shouldn't you be solving global warming? Why would we put resources into something that's this far away? And I think putting the human experience and human face on it helps people understand why we do it. A lot of the stories are experiences that the readers might not necessarily have had. They may not have flown on a telescope, but they will for sure recognize working a night shift, driving up the ridiculous safe roads to observatory summits, and recognizing being really tired and frustrated, but loving what you're studying and wanting to keep going. I also like the of astronomy as a planet-wide source of joy. There's very few things that are planet-sized in nature. Ironically, the pandemic seems to be one of them. It's rare that something will really touch every corner of the earth. And unfortunately, we're familiar with that right now for a reason that's very sad and very tragic. And I think that astronomy can be a planet-wide joy. We can all share in the triumph of putting a robot on or taking our first picture of a black hole. And it's something that can really be a happy human experience for the whole planet. So it's something that I try to make clear in the book. So with that, the book comes out August 4th in the US. It comes out August 6th in the UK. Still looking for international publishers. I know that my public agent has talked to some publishers in the Netherlands. And for now, you can learn more about the book at thelaststargazers.com. So I'll leave this up, and I'm happy to answer any questions that folks have. Thank you.
I was wondering about the subtitle of your book. It sounds a bit pessimistic to me. Do we really think that astronomy's explorers are vanishing? Or is that, did you use that as a rhetorical tool, or?
So yeah, the subtitle, it's a bit rhetorical, but it does also look at the idea that, I mean, the exploration that we do is evolving. We're much less likely to travel to a summit in Chile or to travel to the middle of nowhere and really take on sort of that classical explorer role when we're doing astronomy. And part of what I talk about in the book is that the way that we explore is different. We might not be physically going to the South Pole or Chile to do our observations. We may be exploring the wealth that comes out of LSST or something like that. And near the very end of the book, I actually say that I look forward to reading the successor to this book in 30 years, written by somebody who spent a whole career working with Sloan data or LSST data or something like that. Sure, it'll have its whole own batch of stories and adventures. The types of adventures shared here of somebody sitting in a prime focus cage, traveling to the ends of the earth, do seem to become less common. So I wanted to share that story in a way that would make sure that it was down and saved for people. The book is also, it also makes the point that if we want to continue having a lot of astronomy explorers, we need to continue financially supporting science. So that's another point made near the end, that if somebody reads this and says, hey, I want to be one of those explorers, they can. Or if they want their kid to be one of the explorers, they can. But it comes with making sure that astronomy has the resources it needs to keep doing what we're all doing.
I think I have to agree with that. Thanks.
Hi, Emily. Thanks for the great talk. So at the end, you mentioned this point that people don't really know why astronomy is useful or why we do it. So I was wondering, what is your answer to that question? Why is astronomy useful when we could also be looking at, for example, global warming or medicine?
Right. So one thing that I talk about in the book, it's a really common question people ask of, why do you do this? And sometimes it's aimed personally, and they're saying, why are you doing this when you could be doing something else? And I really think that question of why we're doing astronomy instead of global warming is a false choice. And it's something, especially in the US funding climate, science gets faced with this a lot. And we see astronomy. Why are we building James Webb when we could build 10 Keck? Why are we building an extremely large telescope when we could build a radio telescope? And to me, different sides of the same question of, you have to choose what kind of science you can do. And we're able to do so much in science with relatively little funding on the grand scheme of things. I try to make the argument that we shouldn't have to make that choice, that if we put just a little more money into it, means that we can research global warming and astronomy, and we can research, cancer and astronomy, and that we shouldn't have to parse between them. I know a lot also like to make the argument of, what can astronomy do for us here on Earth? And I very much think of it as a gateway. This is the science that winds up on the front page of a magazine or a newspaper, and every little kid loves. It's like astronomy and dinosaurs. Every little kid will get obsessed with scientific questions, and very few of those kids become astronomers. But maybe it gets them to care about their math a little bit more. Maybe they go on to become a doctor instead of an astronomer. Maybe they go on to nothing at all professionally with science, but they see the value in putting their tax dollars towards science. So it seems like astronomy as a way to kind of spark passion about science is a really valuable tool.
Hi, thank you very much for the talk. I really liked it. I was just wondering, do you think that prime focus astronomy, so where the astronomer is actually sitting there, permits more serendipitous mistakes or discoveries? Whereas if you have to write a huge application for observation time, you might not find as many unexpected things, but you're looking for something that you think might already be there.
So yeah, first of all, I heard great tales of literally prime focus astronomy and the things that would happen. Somebody's, hanging above the primary mirror. I heard petrified stories of almost dropping a wrench onto the primary, or of not opening something properly and getting an entire night wasted. But I think what you mean is the sort of classic write something up and go to a telescope, and whether that allows for serendipitous discoveries. I do think it does. And it's a point I make in the book that there's some flexibility in saying, you know, I've got 15 minutes at the end of my night studying red supergiants. I'm just going to look at one LV because Henny told me that there was something we should look at this one LVV. And that last 15 minutes can get you some really amazing science. I've written entire research papers on those 15 minutes. And I think able to be nimble and say, you know, we've got telescope time. Let's just do this one cool thing, really valuable. And I think that that's something that we lose when we do Q-based observing, for example. On the other hand, on a classical night, if I go to a telescope and the weather's too bad for my observations, we're just sitting there, or the time gets lost, whereas somebody else who could have rotated a Q could get amazing science out of that night. So it's a bit of a trade-off in both. I think that serendipity is better served by having an observer at the telescope and the ability to just say, oh, let's just try this one thing.
Thanks. Thank you very much.
Thanks very much for this beautiful talk. That was really inspiring. And I really liked how just you telling a few stories about this triggered like a lot of memories of stories and legends I've heard about observing experiences from people. So I'm sure that there is like probably so many more stories that you didn't get to include in the book. So how did you select them? And are you planning to have a follow-up, like a second book, or maybe a storytelling hour for astronomers or something like this?
Oh, I like the idea of a storytelling hour for astronomers. Selecting them, yeah, it was challenging. I have easily double stories in a file somewhere than I have in the book. And my editors helped me that. I also tried to trim it down because I didn't want to just turn the book into an anecdote collection. Like you said, it's a flood of memories. And the book is written for a popular science audience, but I know a lot of astronomers might read it and will read observing stories all day and just remember what it was like. But a ranger, eventually, like they don't know who all these people are. They don't know the experience personally. So just a story isn't enough. And the book had to have a narrative arc and a story that it followed. So it partly follows my experiences. It partly follows through from how we used to do astronomy to how it's done now. And I was trying to stories that would specifically slot into those. I know I had some categories, like there's a chapter, the chapter with the volcano is focused on what it means when we put observatories out in the middle of nowhere, because you run into volcanoes, you run into snowstorms, you run into tarantulas that are this big, you run into bears. And I remember for that one, my editors came back and they said, you really have a lot of animals. Can you trim them down? And I was like, no, you don't understand. I got heaps and heaps of stories like this. But it was trimming them down to keep it as a well-narrated and contained book. I don't know what I'm going to do with the stories that are on the cutting room floor. A story hour or like a storytelling podcast sounds really fun. I have hours and hours of recordings, but they're raw recordings, so I think bringing people back to retell the stories would be better. I don't have a second version of this book, but I have thought about the sorts of stories that could come next. I completely like space-based astronomy in the book, just because that would have made it unmanageably huge. And like Hubble alone people have written entire books on the building and development of Hubble, and there are many more to come. So maybe there's another window for it there. I keep pointing down because I have a copy of the book. They sent me a little like hard, like paperback copy. So the real copies.
I just wanted to comment regarding serendipity that a few of my friends seriously made the proposal, I mean senior observers, that there should be a rule at observatories of the kind of apply for, succeed in getting 8 hours, get 1 hour free. So as to build in some time so that people can do their crazy ideas at an observatory as well. And it's even been said of papers, maybe for every 5 papers you pass through the referees, you get allowed one with a little editorial comment that says this has not been refereed, so that the crazy ideas can also get out.
There was a funny thing that someone brought up. Oh yeah, somebody brought up the Google 10 free time rule. So Google let, I don't know whether this is still going on, but they let you spend 10% of your time on sort of a passion project.
Yes.
So something that people brought up when I was talking about the way people used to observe. So this would have been back in the for the 1900s into like the 1960s or so, when observing was done, and by being, a professor at Caltech, you automatically got time on Palomar. He was mentioning Martin Schmidt, because he would take a break during lunch. Everybody used to take at like midnight and leave the telescope and go down and have lunch. And he would play an hour of pool, the assistant. And I came up under the observing philosophy of like, if it is dark and clear observing, you have to use every minute of time. And I know some younger observers were complaining about Martin Schmidt saying like, look, if you take an hour every night and add it up, that's a whole other night of observing for some new person. But then the argument was made, he was contemplating quasars and thinking about what work he could do while he, like maybe the brain downtime while he was playing pool allowed creativity to happen. But yeah, I think a mix of observing and a mix of telescopes operating in different ways are really what we need. You want the benefits of Q, of robot, and of someone just sitting at the telescope going, what if I point there? And the combination is what's powerful, I think.
I think Gerard Kuiper was more famous for wasting telescope time. Apparently, to the great anger of his colleagues, he once spent a whole night looking through a large telescope at Mars to restore his color vision, and with a large color chart from a paint store, determine whether the exact surface color of a certain part of Mars was Stony Brick Red 5 or Stony Brick Red 6.
I'm sure there's a chemical signature in there that you could,
thank you for the very interesting talk. I'm definitely sold on the book. I wanted to ask you, these days, obviously, equality and diversity are considerations everyone has in mind. Especially in Seattle, I guess. What did you think of something like that when picking the stargazers you wanted to mention in the book? Compile the stories, trimmed them. I'm thinking of creating role models and this kind of.
I did, certainly. Part of looking at how observing has involved how observing access has evolved. And there are no official records of this. I had to dig these up, but I talked to the first woman who PI at the 100-inch telescope at Mount Wilson. That was Anne Bosgaard. And it happened until 1966. Similarly, Vera Rubin became the first woman observing under her own name at the 200-inch, and that didn't happen until 1965. This was an observing-focused book. I wanted to, in the book, look at the big race disparities that we see in astronomy and the fact that we have a very low number of Black astronomers in the US. 1% of astronomy faculty in the US are Black. And I was trying to find things like who was the first Black PI at Palomar or Mount Wilson or at so-and-so. And nobody keeps records of, the first PI was and things like that. So it was almost impossible to find, but the numbers were also incredibly small. So I talked to, for example, Dara Norman or John Johnson and got to read about George Carruthers, or if anybody knows who Arthur B.C. Walker is, he was one of the pioneers of X-ray rocket astronomy. And they were among the sadly very small of African-American astronomers. And talking to people about what that experience was like at a scope, I mean, it's not at all surprising to hear stories like, you're walking into a remote telescope dome and asks you what the hell you're doing there, which is going to happen much more to a Black observer than to looks the way they expect a scientist to look. So the book absolutely looks at this and looks at the low numbers we have in the field in terms of diversity and how we've made progress with women in the field, though it's not a finished job and there's still a lot of progress to be made. So that was for sure included in the book.
Thank Emily again from all of us. I think it was an excellent talk and it was a great end of season for the colloquium as well. And good luck with the book.
Thank you.
Yeah, thanks for being here.